An essential part of Drake University's mission is to provide a forum for thoughtful civil discourse about the pressing issues of our day. There's no issue more pressing than global warming, and there's no observer more thoughtful about the problem than our speaker today, James Hansen. Dr. James Hansen was formerly director of the NASA Goddard Institute for Space Studies in New York City. He's currently an adjunct professor with the Earth Institute at Columbia University. Dr. Hansen has studied the atmosphere of the Earth for many years. He is sometimes referred to as the father of global warming because of his early warnings about the phenomenon in the 1980s. As a leading scientist, his impassioned voice is important to the fight to combat climate change and the negative impact humans are having on our environment. Hansen is an Iowa native and received his degrees in physics, astronomy, and mathematics at the University of Iowa. He studied in Dr. James Van Allen's space science program, initially doing his research on the composition of the atmosphere of Venus. Later, he switched his research focus to the Earth's climate. Using climate models built on information from satellites, Hansen studied the changes in our atmosphere and the effects of these changes on the environment. His research has found that evidence of global warming, which if unchecked will lead to climate change so irreparable that eventually human lives and the lives of thousands of plant and animal species will be in jeopardy. His model suggests that emergency levels have in fact already been reached. James Hansen has been selected by both Time magazine and Foreign Policy magazine as among the world's 100 most influential thinkers. We are lucky to have him here today. Please join me in welcoming James Hansen to Drake University.
Thanks very much. I included the word opportunity at the end of my title because if our political leaders could just see straight, they would recognize that the climate crisis is actually an opportunity to restore our technological and economic leadership. Let's see if I know how to use this. Do I have to point it? Oh, there we go. I passed that one. When I was young, our family was involved in a socially useful activity. My father was educated to the 8th grade, and he was itinerant sharecropper. We would move from one farm to another, sharing the crops with the owners of the farm. And I was the fifth child and the first boy. My 4 older sisters are shown here. Looks like 3 of them might be abusing that friendly milk cow, but actually they're so skinny I don't think she notices anyway. What was the point? But starting out with this, although we started out this socially useful activity, somehow I've ended up on the wrong side of the law and have been thrown in the clink. In fact, I think if I can count right, I'm about a 5-time loser now. And the policemen have been getting burlier. Can't quite control this. Okay. Although I was very lucky, actually, to grow up at a time and place where it was feasible for anybody to go to university. You could afford it. It wasn't that expensive then. And I was especially lucky because I grew up in the 1950s. That was the time of Sputnik. When I went to the University of Iowa in 1959, Professor Van Allen was building instruments in the basement of the physics building. And he built the first instrument on United States satellite, which discovered the radiation belts around the planet. I was much too shy and unconfident to approach Van Allen. In fact, I avoided taking any classes under him because I didn't want him to know how ignorant I was. But I was, and that's actually a very bad strategy for students. You don't sit in the back row. You're much better off if you interact with the professor, even if you have some question about your ability. But I was lucky because astronomy professor persuaded me to take the PhD qualifying exams when I was a senior. And I not only passed the exam as an undergraduate, but I also got a very high score. And so Van Allen noticed me, even though I had not taken any courses under him. And he then suggested, he told me about data on the planet Venus. Microwave observations which suggested either Venus was very hot or else it had an ionosphere. And so I did my PhD thesis on studying that data and went off to join NASA, where I proposed an experiment for Pioneer Venus mission to Venus. And it was a small telescope, 1.5 inches in diameter, and it took this image of Venus, which what you see is sulfuric acid clouds that surround the planet. But the main thing about Venus is we learned that the reason it was so hot was because it had so much carbon dioxide in the atmosphere, which is a gas that traps heat radiation. And while our instrument for Pioneer Venus was being built, we realized that several gases in the Earth's atmosphere, in addition to carbon dioxide, methane and nitrous oxide, were increasing. And that made Earth a much more interesting planet than Venus, since there are people that live here and since the planet is changing before our eyes. So I resigned as the principal investigator on the Venus experiment and began to work on trying to build a model to understand what would be the effect of these changing greenhouse gases in the atmosphere. And in about 5 years, we produced a paper which was published in the journal Science in 1981, in which we pointed out, based on observations at meteorological stations around the planet, that the planet was getting warmer, and it had warmed by about 0.4 of a degree Celsius, about 0.7 of a degree Fahrenheit, over the previous 100 years, which agreed with the calculations from our climate model. And we predicted that the 1980s would be the warmest decade in the century, and by the 1990s, the global temperature would rise above the natural variability level. And in the 21st century, we would see the creation of drought-prone regions in North America and Asia, the opening of the fabled Northwest Passage in the Arctic, and beginning of melting of the ice sheets on Greenland and Antarctica, and the rising sea level. Things which have, in fact, since been observed. That paper was reported by Walter Sullivan, the writer for the New York Times, on the front page of the New York Times, and that led to invitations to testify to Congress, which I did several times in the 1980s. And in 1988, which happened to be extremely hot summer with a strong drought that essentially dried up the Mississippi River, and I said during that testimony that it was time to stop waffling and recognize that the planet was getting warmer and we were beginning to see the effects of that. There was a lot of reaction to that. That on the Sunday news programs, I realized after my testimony that some people may misunderstand what I was saying, because the warming is still, and especially at that time, was still small enough that all it does is affect the probability of a given season being warmer than normal. So I made up these colored dice to try to show that what we were doing is loading the dice. The natural variability is still very large, and here I was with Michael Oppenheimer, who's another scientist, and I decided at that time that I really didn't like the public aspect of this. I prefer to do the science. And so when I received requests from the media, I would refer them to Michael or to Steve Schneider, who was a friend of mine and a very articulate, much better speaker. But however, I wanted to testify once more, because I also realized that because there was a drought that year, that there may be misunderstanding that global warming means just more droughts. Well, in fact, it means you make both extremes of the hydrologic cycle more extreme, because as the planet gets warmer, the atmosphere holds more water vapor. So at the times and places, and whatever evaporates comes down someplace. And when it does come down, there's more of it. So you get heavier rains and stronger floods. So the 100-year flood, what was the 100-year flood, will become more frequent than once every 100 years. However, what happened was I did testify again in 1989, and unfortunately, my testimony was changed by the White House, the Office of Management and Budget, and I told the chairman of the Senate committee about that, and so he told the newspapers, and it ended up on the front page of the New York Times, and there were a lot of cartoons about that, including one in the Des Moines Register, which was fairly direct. By the way, it may look like, from what you read in the newspaper, it may look like I'm battling with the Republican administrations, but in fact, I've had equal amount of trouble with Democratic administrations. It's all in both parties, when they're elected and take over the White House, they feel that government employees are all working for them and need to support whatever they're saying. And I always felt that my salary was being paid by the taxpayer, and I should simply tell what I see as the truth, not what the administration wants. But in fact, in both administrations, a government employee testifying to Congress must first give his testimony to the White House, and it can be changed there and is changed there. And I had thought, I'd tried to make a big issue of this before Obama was elected. I thought maybe something would change. It hasn't changed at all. And also, the other thing that has not changed, the public affairs offices in all the science agencies are headed by political appointees. So if another party wins the election, the heads of the public affairs go out, and they feel that their job is to make the president look good. It doesn't make sense, in my opinion, in a democracy that the science should depend upon who's president. So anyway, so for 15 years I stayed out of, tried to stay out of the media. And even when my first grandchild was born, it still didn't really sink into me. I showed this photo only because, when I gave a scientific talk, only because the day before I'd been called in the newspapers the grandfather of global warming. And I wanted to show that I was a real grandfather. And, then, at the beginning of the younger Bush administration's presidency, I had the opportunity to meet with the president's Energy and Climate Task Force, which was chaired by Vice President Cheney. In fact, I got to speak with them twice, but our science had no impact on their policies, which were basically to go after whatever fossil fuels they could find and to build 100 new coal-fired power plants, for example. While what the science tells us is that the part of the fossil fuels that we've burned, the purple parts of oil, gas, and coal, by burning those, we've already burned most of the carbon that we can afford to burn. If we burned all of this, we know that we would end up eventually with no ice on the planet. Sea level would be 250 feet higher. It's crystal clear, the science is crystal clear that we cannot burn all the fossil fuels. And yet, we have not been able to get that message to sink in. So I decided, and that was 2004, I decided I wanted to try to give a talk. Well, first of all, I decided that we couldn't influence that Bush administration, so I decided I was going to vote for the Democrats, thinking that John Kerry would do a better job. I wanted to try to make this climate science story clear, and there was an organization that was going to sponsor a talk in Washington, D.C. and try to get publicity for it. But when it got, so I spent 6 months preparing this talk and writing a paper which would go with it to back up the science. But by the time I said I was ready to give the talk, they chickened out because they were afraid that Bush would win the election and they would live to regret it. So therefore, I still wanted to give the talk anyway. So I contacted Professor Van Allen at Iowa City, and he arranged a so-called distinguished lecture at the University of Iowa. And I gave this was one of the charts that I'd prepared for that talk, where I was getting then I had 2 grandchildren, and I was getting them to help explain how the greenhouse effect works. By blocking the heat radiation, it's as if we were putting 2 of these 1-watt Christmas tree bulbs over every square meter of the Earth's surface. That's the amount of heating that those gases provide. But it ended up, well, this talk was not appreciated by the administration, and when a year later, I gave the talk at the American Geophysical Union annual meeting, and by that time had additional data. 2005 was the warmest year in the instrumental record. And right after my talk, there were calls from the White House to NASA headquarters, and then I received a message from NASA headquarters that I could not give public talks anymore without prior approval from headquarters. And in addition, if the media contacted me, I had to tell NASA about it, and they would decide if someone else would be a better contacted me. So after that had happened for a few weeks, so that I collected the evidence on what was going on, then I told the New York Times about it, and then the policy got reversed, and NASA got embarrassed, and they had to change the policy. This was one of the additional cartoons. However, there were repercussions of that. I could then speak out. However, within a couple of weeks, the statement that I had been using to justify my talks, namely that the first line in the NASA mission was to understand and protect the home planet, well, that line disappeared. And it was taken out by the administrator without asking anybody else. And also, the budget for climate research and analysis was reduced 30%, retroactive to the beginning of the year. In the meantime, I had more grandchildren. This is my son's first child, Jake. And not too long thereafter, Jake had a baby sister. Now, Jake thinks that he can protect his baby sister. This is a photo of him when Lauren was 2.5 days old. But Jake has a peanut allergy, which on a scale of 1 to 10 is a 10. He can't go anyplace without an EpiPen. So for us what we're doing is putting young people in this position where, we should be protecting their future, not making them assume that they've got to do that. But so I thought, well, that our government was particularly thick-headed, but I thought, well, other countries will understand the situation much better. Well, what I found in going to 10 or 12 countries was it's not much different. In every one of these countries, with maybe one exception that I will mention, fossil fuel industry is very powerful, and money talks in the capitals of all these countries. This is a chart for the carbon intensity of the energy in different nations, and I just wanted to point out that one nation, Sweden, has reduced its carbon intensity close to the level that you would need to stabilize atmospheric CO2. The way they've done that is to completely decarbonize their electricity, which is 50% from hydropower and 50% from nuclear power. If all the countries could decarbonize their electricity, we could solve the problem, because we can make hydrocarbon liquid fuels for vehicles. The reason that they still have 25% carbon is because their vehicles are powered by gasoline. But we could replace that. If you have energy, abundant energy, you can make liquid fuels out of carbon out of the atmosphere and hydrogen. But what's actually happening is the carbon emissions are increasing. In fact, they're increasing more rapidly in the last decade than in previous decades. And temperatures are going up. The last decade or so, these are annual temperatures, and then they're 5-year and 11-year running means on the right. And the rate of warming has slowed down in the last decade or so, but that's just part of the natural variability. We know that the planet is continuing to get warmer, and each decade is going to be warmer than the one before. the thing that confirms that is we can now measure that the planet is out of energy balance. There's more energy coming in than going out. And we can now measure that quite accurately because the atmosphere is very thin. It has a very small heat capacity, but the ocean is deep and has a large heat capacity. And so that's where the extra energy has to go. So in order to know the energy balance, we just have to measure the temperature throughout the ocean accurately. And now there are more than 3,000 Argo floats spread around the world's ocean that dive down to a depth of 2 kilometers and then come back to the surface and radio their measurements to a satellite. And what we find is that the heat content of the ocean is increasing at a rate of about 3/4 of a watt per meter squared. That doesn't sound like a lot, but it's equivalent. 3/4 of a watt is equivalent to exploding 500,000 Hiroshima atomic bombs every day, 365 days a year. That much energy is going into the ocean. And that energy will have consequences. One thing it means is the planet is going to keep getting warmer. There will be fluctuations year to year, and even some decadal oscillations. But if you look at the last 5 or 6 decades, each one has been warmer than the one before. And so far, the first 3 years of the present decade are only about the same temperature as last decade. But by the end of the decade, it will be warmer because of this energy imbalance. We know it's going to keep getting warmer. The last 4 years, you may remember 2012, in the upper right-hand corner, you can see the United States was one of the hottest regions on the planet. You probably remember that summer. It was I think, the hottest summer in the Midwest. But now, the last year, the eastern 2/3 of the United States was quite cool. And this year, the eastern 2/3 of the United States is the coolest place on the planet relative to what's normal at each place. So these are temperature anomalies relative to normal. Well, that's just a matter of how the weather patterns shift from one year to another, how the jet stream is waggling at any particular time. But the chances of being under a hot spot are continuing to increase, and the extremes, so you better enjoy this year. The situation is that we have a crisis, even though it's not well recognized. Because of the inertia of the system, the ocean does not warm up quickly when we change the composition of the atmosphere. So we've only experienced about half of the eventual warming of the gases that are already in the atmosphere. So the danger is that we're going to push the system beyond tipping points where events begin to occur which are out of control of especially of the young people who will be inheriting this situation. Those consequences that I think are most important are those that are irreversible. That includes extermination of species. It also includes the disintegration of ice sheets, because if Greenland or Antarctica disintegrates, it takes tens of thousands of years to build up an ice sheet by snowfall piling up. So, let me just mention these, each of these. The threat the problem we're causing with other species is partly due to the shifting climate zones as the planet gets warmer. But that's being combined with stresses that we put on other species in many different ways. I use, as an example, I like to use this insect, the monarch butterfly. The main stress that we're placing on the monarch is the chemical Roundup, which is used by farmers to kill weeds, and it includes milkweeds. And that's the only plant that the larva of a monarch can eat. So that when I can remember when my wife and I were younger, we could see a dozen monarchs at the same time in a field. Well, now you don't see any, or maybe you see one. This particular female monarch, which I could identify because part of her wing was broken off, she hung around our yard as the only monarch for a few weeks in 2011, and she produced, you maybe can't see them here, but she produced about 25 or 30 of these caterpillars, which then crawled off into our privet bushes, and well, you can see two of them are emerging from their chrysalis at the same moment. One of them is a female and one is a male. That's the male and that's the female. And we wondered how many of those monarchs would make it to Mexico. You know, this monarch is an incredible insect. It migrates all the way from this mountainous region in central Mexico, all the way up the east coast of the U.S. and through the Midwest also, up to Canada, and then migrates back for the winter, before the winter, back to the same little area on this mountain. How it can find its place is a mystery, but we wondered how many of them, and it takes 3 or 4 generations to make that round trip. We wondered how many would make it to Mexico because they had to go through Texas, which had a tremendous drought in 2011. Well, I wrote an article about that monarch, and Mexican scientists sent me some photos. This is a branch of one of the fir trees where the monarchs end up in Mexico. So there were a lot of monarchs that made it. That's his grandson looking up at the monarchs. But what they saw in addition to these monarchs was the trees were not doing very well, these fir trees, because of these shifting climate zones. They're now having frequent droughts, and which is affecting the trees. So he's trying to persuade the Mexican government to plant these fir trees higher up the mountain where the climate is more appropriate. This is actually, you know, last year I only saw a couple of monarchs. One of them was a male, which came and landed on our butterfly bush and on the milkweeds, but then he just flew all around the yard and around the barn and everything for a couple of hours. And I finally decided, well, so my concern about this insect is that now we've reduced their population to the point where they may go extinct because there are not enough of them. They don't travel in pairs like birds. I remember when I was a paper boy, where the newspaper Omaha World Herald would always have this little line at the bottom which told us the number of whooping cranes that were making it to the wintering ground in Texas. And they almost went extinct. They got down to about 20 or 23 or something. But they traveled together, you know. But in the case of these butterflies, the male and female have to meet up by chance, and there just aren't enough of them. So my suspicion was this male was looking for a female. Well, now the number that made it to Mexico has continued to decline dramatically over the last 3 years. So it could very well be that the monarchs, at least those in the eastern part of the country, may go extinct. But if we would continue to have the milkweeds, then I think they may come back, because there are also western monarchs west of the Rockies. And anyway, this story is getting too long, so let me go on and say that the coral reefs are the site of more than 1 million species around coral reefs, and they are threatened because the oceans are getting warmer, which causes the coral to expel their symbiotic algae, and the oceans are getting more acid. And so animals that have a carbonate skeleton, like coral, are in trouble if the ocean continues to get more and more acid. That acidity is due to the carbon dioxide, which is getting taken up by the ocean. And we're losing about 1% per year of the coral reefs. So that's another reason why we have to limit the amount of CO2 in the atmosphere. Now, the ice sheet disintegration, the main problem here is that Greenland and Antarctica have ice shelves, tongues of ice that go out into the ocean. And as the ocean gets warmer, it melts those tongues of ice. But those ice shelves buttress the ice sheet. And so once the ice shelves are gone, then the ice sheet starts discharging ice into the ocean more rapidly. And also, you get more summer melt on Greenland, the red area. And the meltwater will burrow a hole in the ice sheet, go to the base of the ice sheet and lubricate it, and that also increases the speed of discharge of giant icebergs. So in fact, both Greenland and Antarctica are now losing mass. We can measure that mass of these ice sheets very precisely from gravity satellites, which measure the gravitational field so accurately that you can see changes in the mass of these ice sheets. And they lose mass in the summer, and then they gain mass in the winter as snowfall piles up, but they're losing mass faster and faster. And Greenland is now losing a few hundred cubic kilometers of ice per year. And even more serious problem, I think, is the ice shelves around Antarctica, which are now losing about 1,000 cubic kilometers of ice per year. So it's putting fresh water around Antarctica, which is actually causing more sea ice to exist around Antarctica. But the danger is that the West Antarctic ice sheet will go unstable, and that contains a few meters of sea level. So what we know from the Earth's history is that if the planet gets 2 degrees Celsius warmer, eventually sea level will go up 6 or 8 meters, which would mean all coastal cities would be dysfunctional. That's 20-foot sea level rise is enough to make all of our coastal cities uninhabitable. So we really had better keep global warming from going much higher than what it is now. And finally, to mention just a few words about climate extremes. We're beginning to see an increase in climate extremes. That's the seasonal mean temperature is variable, and it can be described by a so-called bell curve. Some summers are warmer than average and some are cooler than average, and they form a normal distribution. But what we see happening is that bell curve is moving to the right. It's moving toward warmer temperatures, so that what were unusual anomalies that occurred only a few percent of the time are now occurring much more frequently. And the red area are warmer than average, blue colder than normal, and where normal is last century's climate. But now, so we can still have some seasons that are colder than the average in 1950 to 1980, but that's less common. And now we can get more of these extreme events on the right. And when you do get those extreme events in the summer, that'll be where you have high pressure and it's dry, and then you tend to get fires which burn hotter. So they're more damaging than forest fires used to be. And we see more of this happening. partly for other reasons, our forest management, for example. But we also, as I mentioned, because the atmosphere holds more water vapor, you get more extreme floods, and we see that happening. And those storms which are driven by the energy in water vapor, latent energy in water vapor, can become stronger. It doesn't mean every storm will be stronger, but you have the potential for stronger storms. And in the case of this Sandy, the reason it was able to remain a hurricane all the way up to New York City because the ocean waters along the East Coast were warmer than normal, and they provide the energy for the storm, and which then actually combined with a frontal storm and went all the way to Lake Erie and caused quite a bit of damage on the East Coast. And even caused politicians to briefly make note of the fact that they had been completely ignoring the climate issue. And I think that's our old milk cow who's getting thrown around up there in the upper right. Okay, so as I mentioned, we can't burn all of these remaining fossil fuels, but that has not sunk in. It's possible to stabilize climate, but we would have to phase out coal, and we would have to not develop the unconventional fossil fuels. But what's actually happening is our leaders are encouraging the development of every fossil fuel that can be found. Going to the deep ocean, going to the Arctic, mountaintop removal. And this, unfortunately, is a case of intergenerational injustice because we're burning the fossil fuels and getting the benefits of it, but the problems are going to be borne mainly by young people in the next generation. And our parents didn't know that they were causing a problem, but we can only pretend that we don't know. Which is kind of strange because historically, our founding fathers recognized an obligation to future generations, and Native Americans, indigenous people, have that in their way of thinking, and most religions think we have a duty to preserve creation, but our government leaders don't pay much attention to that. And the public is not very well informed and doesn't get involved. They have enough problems today without worrying about what's happening in a few decades. The fundamental problem is that fossil fuels appear to the public to be the cheapest energy. They're not really cheapest because we subsidize them, and indirectly we protect the supply lines. Our military is a big cost, and that's involved. But the main thing is, if we would just include the effects of the air and water pollution from fossil fuels and make the fossil fuel industry pay for those costs, then clean energies could compete very well with fossil fuels. But if your child gets asthma from air pollution, you have to pay the bill. The fossil fuel company doesn't. And the climate effects, which are beginning to have an economic impact and will have much greater in the future, are also borne by the victims and by the taxpayer, not by fossil fuel companies. So what we should do is add a fee, collect a fee from the fossil fuel companies at the source, at the domestic mine or the port of entry. And that fee should gradually rise over time so that people have time to adjust to the changing energy prices. And the public's only going to accept this if the money goes to the public that's collected, because a rising carbon fee is going to cause the price of gasoline at the pump and Electricity, if your electricity is coming from coal-fired power, it's going to make that more expensive. So what you want is to give the money 100% to the public, an equal amount to each legal resident. That way, the person who does better than average in limiting their fossil fuel use will make money, and they will give them an incentive to pay attention to their carbon footprint. And it will give an incentive to entrepreneurs to develop low carbon and no carbon products, and to businessmen to take account of their carbon footprint. So that would be a transparent, market-based approach, and it would not enlarge the government. It leaves the individual decisions to the individuals. That's a conservative plan, and it would stimulate the economy. There's been an economic study by the Regional Economic Modeling Incorporated, REMI, which looked at this plan specifically with assuming a $10 a ton carbon fee, going up $10 a ton each year. So after 10 years, $100 a ton. After 10 years, that would reduce, they find that it would reduce U.S. emissions 33%, which is 12 times more than the amount of fossil fuels that would be carried by the Keystone XL pipeline. So it's much more effective to put a price on carbon than to try to find another dirty fossil fuel. It would result in 2.1 million new jobs in 10 years. After 20 years, emissions would be reduced 52%, and there would be 3-point-something million jobs created by that. So, and this, a carbon fee is the only viable international approach. You know, what we've tried to do with the Kyoto Protocol is a cap and trade. But that means you have to ask each country to have a cap. You've got about 180 countries to argue with. And what cap would India accept? India, well, the United States is responsible for more than a quarter of the excess carbon in the atmosphere, even though our population is, about 5% or something of the global population. And if you look at per capita contributions to the excess carbon in the atmosphere, the United States is 20 times more than India. So India is going to say, well, our cap should be the United States. Why shouldn't we get as much a cap as the United States? There's no way to win this. The way you could get it to work with a carbon fee, the United States and preferably China would agree to have a carbon fee. And China is much more ready to do that than the United States is, because they want to reduce their fossil fuel use and their air pollution, which is incredible. And they're in line to really get hammered by climate change. They have a few hundred million people living near sea level. So if the U.S. and China would agree to have a carbon fee, then they would put a border duty on products from countries that do not have an equivalent carbon fee, and that would be a tremendous incentive for the other countries to have an equivalent carbon fee so that they can collect the money themselves rather than have us collect it at our borders. It's a big job because our energy, this is the U.S. energy, so most of our energy is coming from fossil fuels, coal, oil, and gas. Nuclear provides a significant amount, and we've been trying for a few decades to encourage renewable energies, and we've now got them up to about 3%. But that's a small part of the total, and that's similar to the rest of the world. The rest of the world uses a bit more coal, but their renewable energies are also about 3%. So I think, and you know, the rate of growth of fossil fuel use per year for the last decade or so has been about 3%. So that means our 20 years of effort to get more renewable energies is matching 1 year's growth in the fossil fuel use. So it's important. We need to move, and we need the incentives to move to clean energy that would be produced with a rising carbon fee. But we shouldn't kid ourselves into thinking that renewable energies on any reasonable timescale are going to provide all of our energy. They're a small piece of that energy. I'm not sure I can get this to work. I guess not. I'll try it. Oh, it was going to work.
Sorry.
Now, let me try that.
Hold on, let me do it.
Okay, you do it? 200,000 people here in New York City.
Or shall we say, when we stop nuclear power, we will usher in throughout the United States and the world a new energy alternative. The sun which Exxon doesn't like because it's free, it's abundant, it can bypass Exxon. Stopping atomic energy is practicing patriotism. Stopping atomic energy is fighting cancer. Stopping atomic energy is fighting inflation. Stopping atomic energy is saving this country.
I want the energy that we have now. We have to have either oil or coal or whatever, but certainly not nuclear. Even wood if need be. I have a coal stove at home if you want to know. Flash! Yes. Put it on. I don't use it now, but if I have to, I will. And I live 1 block from the mayor, and I have a coal stove. Put that in your house and smoke it.
We'd like to sing the John Paul Johanna Hall song for you to become sort of the song of our movement. Just give me the warm power of the sun. Give me the steady flow of the waterfall. Give me the spirit of living things as they return to clay. Just give me the restless power of the wind. Give me the comforting glow of the wood fire.
Okay, so, yeah, they want the comforting glow of a wood fire and coal or oil, but not nuclear power. There's a study, the World Health Organization published a study this year in which they conclude that the number of people dying from outdoor particulate air pollution is 3.7 million per year. And in addition, indoor air pollution, which is from burning wood and field residue and coal and cow dung, various fuels are used in the developing world, kills 4.3 million people per year. And especially the people affected by this are women and children in the kitchen. But in contrast, we had a nuclear accident in the United States, in Pennsylvania, in which residents of Pennsylvania got exposed to nuclear radiation. And if you believe what's called the linear no-threshold theory, which says that we understand the damage that's caused to the human body by a very huge amount of ionizing radiation, And if you assume that that continues to be true, even for small amounts, it just linearly decreases, then you would conclude that 3 Mile Island could result in 1 or 2 early deaths due to cancer among a Pennsylvania population, which will have 40,000 people die of cancer due to other reasons. But in fact, a lot of the scientific evidence actually points to the fact that the likelihood that low-level radiation is not harmful. But it has just become a political advantageous to politicians to take advantage of this nuclear fear. There's a very good book by Spencer Wert, which is called something like how the origin of the rise of nuclear fear, but in any case, when Bill Clinton was elected, in his first State of the Union message, he announced that that he was eliminating any further research and development on nuclear power, which was very unfortunate because our top laboratory, Argonne National Laboratory, was ready to build a 4th generation nuclear power station, which are present. The technology that we're now using is 50 years old, and it burns, this light water reactors burn 0.6% of the energy in the nuclear fuel, and the remainder is left in a waste pile which has a half-life of more than 10,000 years, so you have to babysit it forever. But if you allow the neutrons to move faster, you can burn more than 99% of that energy. And you can also burn nuclear waste and solve our nuclear waste problem. You can also burn excess weapons material, which we have an enormous amount of built up during our Cold War with the Soviet Union. And also, we now have technologies which can shut down. If the reactor has an anomaly, if there's an earthquake or something, it can shut down automatically, and you can have a cooling system that will cool without external power. So the problems that plagued Fukushima, for example, we now have the technology to avoid that kind of problem. It makes no sense, in my opinion, that we bail out of nuclear technology because the rest of the world is not doing that. What we will be doing is making the world a much more dangerous place because Russia is all too happy to provide nuclear power to other countries. They're taking orders now, including 4th generation nuclear fast reactors. We need to allow, what we need to do is put a price on carbon that continues to go up and then allow the alternatives to compete. And we should really be technological leaders, and it would be in the economic interests of young people if we're leaders technically, and that is finally beginning to sink in, I think, but we're running out of time. And unless we put a price on carbon, then these emissions are just going to continue to go up. So the one source of optimism for me is this organization, Citizens Climate Lobby, which has been growing rapidly, the number of groups almost doubling each year for the last 4 years, and they are advocating a simple carbon fee with the money given back to the public, and they go to Congress, meet with congressmen, or if the congressmen won't meet them, they meet with the staffers, and they are polite and persistent, and they come back again the next year, and they write op-eds and letters to the editor. And if they double several more times, maybe the public will become aware, more broadly aware of this, because the solution of this problem is not difficult. It's not painful. It does not, the false story that is out there is that dealing with climate change is going to be very expensive, so we don't want to do it. Well, that depends on how you do it. If it doesn't, as the economic studies have shown, if you actually give the money to the public, it does not depress the economy. Increase in taxes depresses the economy. But if you take a fee from the fossil fuel companies and give it to the public has plenty of need and uses for money, and it stimulates the economy. And it will do it because of this rising fee. It will cause us to move to clean energies, renewable energies, possibly nuclear power. If we don't, we know China is building 30 or 40 nuclear power plants now, and we're selling them some. The Westinghouse has the best present light water reactors, and China is buying them, but we should be going to the still better technologies, and then we could be selling them to the world, and we would help maintain a safer world, because you can do nuclear technology in ways that are much safer than the old 50-year-old technology. But we don't really need to get wrapped up in the nuclear argument if we simply say, let's put a price on carbon, let that rise, and let the alternatives compete. Thanks.
So Dr. Hansen will take some questions now. I'd like to ask that if you have a question, please come up to one of the microphone stands and line up here. Dr. Hansen will call on you alternatively. Also, please resist the temptation to give a speech. It'd be nice if you could offer a brief question so that we can get to as many different questioners as possible. Thank you.
I'm supportive of the carbon fee and dividend, but I have a question for you on kind of a more micro level or individual level. I've read a lot about how animal agriculture has a kind of a multiplied effect on the atmosphere because of methane and nitrous oxide having, being more potent and shorter time in the atmosphere. But I don't hear much about that, so I wonder if that's inaccurate. And I just wondered what you have to say about that.
Yeah, both methane and nitrous oxide are increasing. About 85% of the increasing greenhouse effect is CO2. And it has the longest life. The CO2 that we put in the atmosphere will remain in the climate system for many millennia. It will get partly mixed into the ocean and into the soil, but it won't go back to the floor of the ocean in less than many millennia. So it is the biggest issue. However, these other greenhouse gases are not negligible, and it is true that eating meat is harder on the planet. You will produce more greenhouse gases, and it takes more energy than a vegetarian type lifestyle. But And so if you want to make a personal contribution to reducing greenhouse gases, you may change your diet, but the real issue is the carbon dioxide, and it's the fossil fuels. Methane is increasing slowly, but there are several sources. One of them is animals, but also leaking from fracking for gas, and at the other fossil fuel, at coal mines especially. In fact, the biggest sources of methane in the United States are at coal mines, where inadvertently you let methane into the atmosphere. So those are significant and shouldn't be ignored, but if we don't handle the fundamental issue, then those minor ones are not so important.
Hello. My question is about the Arctic, and I was wondering if what's your reaction to the Department of Defense's statement about climate change, and their statement about the Arctic was that, well, we have to get in there with bigger boats and defend our territory and exploit the resources while we can. And they don't seem to have any regard to keeping the fossil fuels in the ground.
Yeah, well, the military also said, military leaders have said in the past several days, that they recognize this climate change as being one of the biggest threats to the nation because of the disruptions it's going to cause globally, particularly as low-latitude countries have a hard time feeding their people, and the higher temperatures are particularly harmful at the tropical latitudes. But as far as the Arctic is concerned, yeah, it is unfortunate that it is seen as a potential resource. And because Russia sees it as a resource, the U.S. is not going to ignore it. Again, that resource is more expensive. It's more expensive to get that oil out of the ground and get it to the market. So if you do put a rising price on carbon, that tends to be one of the fossil fuel that would come off the table first. It would become less, if it's not economically beneficial to oil company, they're not going to drill there. So what we have to do is move the economic system off of fossil fuels. I mean, it's unthinkable to many people, but in fact, it has to happen. Otherwise, young people are really in trouble. And it could happen. You know, there's a lot of technical possibilities, but they're not going to be spurred without the incentive. As long as we allow fossil fuels to be dirt cheap, then people will keep going after them and making money by finding them. So that's why it's so crucial to get a price on carbon, which allows alternatives to compete.
Dr. Hansen, thank you for coming. I was wondering if you could expand about the times you were arrested and also how you made the decision to commit civil disobedience.
Well, the first time, once you get started, then it gets easier the second time. And the first time was in West Virginia, where it was such a crazy situation where they're doing this mountaintop removal, and the health of the people there is really being damaged because they just push the tops off these mountains into the streams. and then the water gets polluted. And so the life expectancy of people is noticeably reduced there. And it's just, you know, you're just destroying the environment. It makes no sense. You're getting this 6-foot thick seam of coal and destroying the mountain to get it. It's a crazy thing. But in particular, so I got told, I gave a talk at Virginia Tech, and the students told me about Larry Gibson, who owned some property on this one mountain. He refused to sell it, and so the coal company couldn't mine that mountain because of that one property there. But they were threatening him, and there were bullet holes in the side of his cabin from drive-by shootings. But anyway, so I did go to, the students persuaded me to meet this guy, and I learned at that time that the coal company had built this sludge pond above an elementary school, and it was just an earthen-based sludge pond, so that if you got very heavy rains, there's a danger that it could give way, and it would just bury that school totally. So we were wanted to ask the coal company to build a new elementary school to replace that one. And anyway, we got arrested for reading this request in front of the coal company, and the idea was, you know, to try to draw attention to the crazy situation. It did actually end up somebody donated money for a new school, but it wasn't a coal company. But anyway, that was the first step, and then the others with tar sands and getting arrested as students asked me to sleep out on the Boston Commons with them to protest the coal burning by the university. And so we got arrested there. So anyway, I kind of come to the conclusion I'm not running off to get arrested now, because I'm trying instead to get this conservative approach. And you know, I come from the red end of Iowa, which, you know, Iowa's kind of a purple state, but the small town western Iowa is pretty conservative. And I basically think conservatives have a very good reason for, they don't really, it's not that conservatives don't believe science. What they believe is that the Democrats are going to increase taxes, and they're going to increase regulations, and they're going to increase intrusion into people's lives. And so I think what we have to do is persuade conservatives that what the solution to this actually is a conservative solution. And it's what we need to get this country moving again, to get us to be technological leaders and to have our economy grow, and so young people have a prospect to be perhaps as wealthy as their parents were. So I'm more focusing on that rather than getting arrested. But we still have a ways to go. But I frankly think that most conservatives are kind of understanding this, and even conservative politicians understand this, but they're afraid to stick their neck out right now, because the extreme right wing will hammer them if they say climate change is real. But if they don't admit that pretty soon, nature is going to make it clear that it is, and then they're in trouble. And then the public will elect the Democrats who increase the taxes, who increase the regulations. So they better come to their senses.
Yes. I had a question. In your opinion, do you see natural gas as a transition energy source as we move more towards renewables?
Yeah, natural gas has only half as much carbon as coal. And so if you start having a rising carbon fee, then natural gas is going to displace coal. You'll soon have no coal-fired power plants, but you would, because it's the quickest thing. It's easy. You can build a gas plant very quickly. And so that's where utilities would turn. But if that fee keeps rising, then eventually you're going to replace the gas with something that's no carbon, whether that's renewables or nuclear or something that we don't even know about now, but which would be spurred by that rising fee. Go ahead.
Dr. Hansen, in light of the substantial and ongoing efforts by the fossil fuels industry to lobby for their efforts and their interests, and also to obscure the climate science, as well as the failure of Congress to be a meaningful participant in any national or international efforts to curb GHG emissions, do you really think that there can be a timely political and legislative solution to our climate change problem? And if not, can geoengineering or some technology save us from a climate disaster?
Well, I think that when things happen, when things change, they can sometimes change quite rapidly. You'll be surprised. Who would have thought 10 years ago that gay rights would be where it is now? It suddenly changed, and even in both parties end up they have to support that. I think what I'm afraid of is that we'll waste another 10 or 15 years, because if this next round of negotiations at Paris next December 2015, if that again is an attempt to put caps, to ask countries to have caps and cap and trade like the Kyoto Protocol, then it's practically worthless. Emissions will continue to go up globally because developing countries want to get wealthier. They have every right to try to be. And so it's, I think it will happen pretty quickly when it happens, but it's important that it happen in the next few years and not 20 years from now. And if it does happen 20 years from now, then your second part of your question becomes very relevant. What do you try to do, geoengineering? Well, for some things it may be too late then. I think I'm working on a paper, which I hope to have done in a few months, which is titled Ice Melt, Sea Level Rise, and Superstorms. And what it deals with is this effect of the warming ocean on the ice shelves. And the problem is that once you've got the heat in the ocean, you can't get it out easily. And that melting of the ice shelves may be out of our control. And that means that we could get sea level rise of several meters. So what would you try to do, geoengineering, to counteract that? Well, you'd try to restore the planet's energy balance. And so the geoengineering ideas are, well, let's put sulfate aerosols in the stratosphere, reflect sunlight away, and restore the planet's energy balance, or even make it negative so it starts to cool off a bit. It's a thing which young people may very well have to make up their mind. Do they want to do? Which is a greater danger, letting things continue to go or trying to deal with it in that way? But hopefully we don't leave them with that question. If we would just get on a carbon price within the next few years, I think it would go very fast. I think, as the REMI study shows, you could go down tens of % quickly. And then we would move rapidly and leave fossil fuels in the ground.
Thank you for challenging us this evening. I'm interested in knowing how you see the carbon fee being set. Who sets that? How does that come into being? And if that's a more complicated question than you can answer or want to answer right now, could you steer us to some reading that we can do in that arena?
Well, the value, there was a bill introduced by a congressman for a carbon tax. He was not giving the money to the public, but it was at essentially this level, at going up $10 a ton each year. That's pretty stiff, although ExxonMobil, you know, we have some people who try to paint the capitalism as the enemy, you know, that but in fact, I find that the captains of industry, the leaders of our industry and CEOs, heads of utilities, are actually pretty capable people. You don't get to be a CEO without being pretty smart. And most of them say that if the government would give the right incentive, they will help solve the problem. The utilities want to have the knowledge that the carbon fee is going to do this, and then they'll change their investment. Instead of building a coal-fired power plant, they'll build renewable or whatever. But we need to give them that incentive. I forgot what your question was. I started wandering.
Well,
The $10. How much should the fee be? Well, that will actually, you know, what will happen once we start with a fee. Most people are going to like this because most people will get more in their dividend than they pay in increased prices. And so they will encourage it to continue to go up. And exactly how fast it goes up is probably not that important. It's just the knowledge that it's going to keep going up. Because when you buy a new vehicle, you're thinking, if you really know that gasoline prices are going to keep going up, then that will affect your decision. And exactly what the rate is may not be too important. But what ExxonMobil recommended was $80 a ton, which is a lot. That's a lot.
We can certainly do a lot more, but Iowa has really led the way in renewable energy nationally and globally. What is it that's holding us back from truly investing in renewable energy? Why hasn't it been the solution that we've wanted it to be?
Because it's not, in truth, it's not money-making if fossil fuels are allowed to be cheap. So, for example, I put solar panels on my barn. And I have a big barn, a 3-story barn. It cost $75,000. But it made economic sense because the state of Pennsylvania gave me $17,000 rebate. The federal government gave me $23,000, 30%. And they had passed law in Pennsylvania that the utilities had to buy my excess power. I'm generating twice as much electricity as we use. So the excess electricity, the utility has to buy, whether they want it or not. And also there's a renewable energy credit, which I get to sell to somebody, somebody who's required to have renewable energy credits. So, but the truth is, without those inducements, it wouldn't make any sense. I'll never $75,000. You know, I'd have to live to be 200 to ever get that paid back from from the cheaper energy. So, and the reason is that the reason the fossil fuels are cheaper is because they don't pay their cost to society. That's why we need to make their prices honest, and then these alternatives will really take off. But until that, you know that this kind of a scheme, it's, you know, who's paying for that, for the fact that now, in my case, that investment will get paid off within 20 years, but who's paying for that? Well, the taxpayer and the other ratepayers. The fact that the utility has to buy they just increase their prices, and everybody else is paying for that. So we have to make them actually economically sensible, and that is done by making the cost of fossil fuels honest.
I wanted to follow up on the gentleman's question regarding natural gas. There's been multiple studies saying that there's a large natural gas leakage rate. So the pipelines are leaking, and because natural gas is 90% methane, and methane is over 100-year time scales, 27 times more potent than CO2, the studies argue that natural gas is no better than coal on a long time scale. So would the RIMI study have, or is there a mechanism in which you incorporate this methane leakage rate into your carbon pricing?
Well, you can certainly do that, but I think those concerns are greatly exaggerated. You know, we look at methane in the atmosphere, and it is increasing slowly. But, you know, we have all these hypothesized sources, leaking pipelines at the coal mines, we have methane hydrates, we have tundra melting in Canada and Soviet Union, and we see some methane bubbling out. On the continental shelves, the methane hydrates are bubbling to some extent. But those sources can't be as large as are feared, because we just measure the amount of methane in the atmosphere, and it's only increasing slowly. So, in fact, we can shut off some of those sources, and methane will probably decline, and that will help us out. And we were actually going to need to do that. But if you can identify an indirect source, then you can include that in the price of the methane. But I think those indirect sources are probably pretty small, based on the fact that we don't see it accumulating in the atmosphere.
Dr. Hansen, shouldn't we stop governmental subsidizing and insuring of nuclear power, and let the price of nuclear and carbon rise, and let alternatives succeed?
Nuclear power, the government collected from utilities a certain amount for each unit energy produced by nuclear power to deal with the nuclear waste. So it amounted to more than $30 billion. And they've in effect stolen the money. They have not used it to deal with the nuclear waste problem. And in fact, in my opinion, you shouldn't bury the nuclear waste. It's fuel for future advanced reactors.
I think they're subsidizing to make the reactors also.
On the contrary, our government has been very, has hurt the nuclear industry as much as it could, but by making it so difficult to build a nuclear plant that it takes you 10 or 12 years to build one in the United States. The regulations are such. And the last one that was finished with a Democratic appointed head of the Nuclear Regulatory Commission, Jaczko was his last name. I don't know if I'm pronouncing it right. But he took 5 months to schedule the meeting for the final approval of the nuclear plant. You know, they spent $12 billion building it, and they have that cost of that money. And, you know, so they've tried very hard to damage our ability to use nuclear. So I don't think, you know, that.
Well, if there's an accident, it's our risk.
Yeah. So, you know, as I mentioned, there was an accident. And, you know, if you believed, and if the kind of the worst accident you could think of is the one that happened at Fukushima, where they build a nuclear plant at sea level, and then they allow for tsunamis of only up to 2 meters, and they put their backup power in the basement, and then they put the used fuel in the third floor. So anyway, it was a crazy design to begin with, but you could never completely avoid such human mistakes. But if you believe this linear no-threshold theory that even a small amount of radiation will eventually cause cancer, then the calculations that were made by an advocate for renewable energies argued that Fukushima over the next several decades is going to cause the deaths of 130 people, most of them in Japan. If you compare that with the deaths due to fossil fuels, 3.7 million a year from the air pollution is 10,000 per day. So even if you believe this linear no threshold, it's a small number of deaths. So there's a certain irrationality to the fear of nuclear radiation. If you look at the particles that come out from burning coal, and the small particles, and look at them in a microscope, they're really ugly. You know, why do they not frighten people when they're killing millions of people a year? Can you imagine if a nuclear accident occurred and it killed 10,000 people, which is what's killed in one day by the fossil fuel pollution, that we wouldn't shut down all the nuclear plants? You know, there's a complete asymmetry, which makes no sense at all. Yeah, there's every source of energy has problems, and you know, I didn't show the chart. I would be kind of, I wonder if it's, yeah, there's an interesting chart. This is how many people are killed per trillion kilowatt hours of energy produced. And an interesting one is the number of people killed by solar is larger than the number killed by nuclear. And this is based on actual data. And the reason is pretty simple. It's mostly falling on, my 3-story barn, there's no chance that I would install those panels. That if you fall off a 3rd story of anyway. Also, there's a danger of getting electrocuted. You're attaching electricity. So there's anyway.
Yeah, thank you for doing what you're doing. I think you've made a convert out of me with your plan. While here in Iowa we've done pretty good, we're not moving nearly fast enough to address the seriousness of the issue. I think the conservatives right now, I think there's a faction that are getting really tired of being with the stupid party, and I think they're wanting to change it. Bobby Jindal talked about that a little bit, and to give them, I think this gives them a reasonable way out. As you know, we've got a Senate race here in Iowa that's supposedly too close to call for U.S. Senate. One of the candidates says that they don't understand how humans can be the main cause of climate change. If you had a chance to talk to her, what would you tell her?
Well, of course, the Earth's history actually shows us how sensitive the climate is to changes in the composition of the atmosphere. We have many different ways of understanding that situation. And every scientific body, the National Academy of Science, American Meteorological Society, American Physical Society, they all have come out with very strong statements about this climate situation and the fact that humans have taken over the driving of the system. So I think it would be, I think who we need to talk to is not the candidate, but the voters. Because if Iowa elects a senator and representatives who are deniers, it's embarrassing. And it's also, it's very a big disservice to young people.
So you've mentioned the carbon fee a lot during your speech, and I like a lot of the aspects of it. But in terms of implementing a universal climate policy and getting multiple nations to agree to that policy, do you see, like, is that achievable? Because a lot of nations are going to angle for different policies based on their own economic and social interests. So I was just wondering what your thoughts were on that.
Yeah, in reality, the policies are going to be determined by the big powers. That means the United States and China and a few other. And so what has to happen is we have to get those nations to agree to have a carbon fee. And then, as I described, and as international economists agree, and as the World Trade Organization agrees, a border duties to balance the effect of a carbon fee from nations that don't have a carbon fee or carbon tax is allowable. And so it's actually, the mechanics for doing it are there and are clear. It's just getting some of the major powers to agree to do that. And the United States is actually seems to be the most difficult, because the power of the fossil fuel industry in the United States is enormous. It's not just affecting Republicans. It affects both parties. It's hard for them to see a different way of doing things. And so they propose these things like cap and trade, which are very marginal perturbations of a system, which they think is more acceptable. But when you have the head of ExxonMobil saying, we think a carbon tax as high as $80 a ton is a good idea, or something they're planning, expecting to happen. You know, a lot of the fossil fuel industry even started a couple decades ago, started thinking the governments were going to do something, and then they realized, gee, if we keep sending a little bit of money, it's a trivial amount that they use. It sounds like a lot of money, but compared to their profits, it's a very small amount that they're using for lobbying. And they're able to keep things as they are, and they're making money hand over fist, so why not continue to do it? We have to have somebody with the courage to explain this. You know, when Obama was elected, he had 70% popularity. He could have said, this issue is important, not just for climate, but for national security, for our economic well-being. He could have made clear that this was an issue, and he had then have to talk to the public and explain, yeah, the cost of gasoline at the pump is going to go up, but if he did it in a way such that the government was not taking the money, then the public would understand that. He had the opportunity. Well, now, you know, his popularity is at the other end of the spectrum, so he has no chance of doing that. But we need a next leader to understand this and it could be solved.
Two quick questions. First of all, with solar and wind, part of the problem is the wind doesn't blow all the time and the sun doesn't shine all the time, and the battery technology is still behind. Are you aware of progress being made on that front such that those technologies could move from being peripheral technologies to more mainstream? And then the second question is along your lines. I talk to a lot of people who are educated who say, okay, yeah, I've seen the statistics on global warming, but I'm still not convinced that carbon dioxide and other gases are causal rather than just correlated. There may be something in the Earth's core warming that's causing this. What would you say to those pundits?
Okay, for the first question about, yeah, that is the difficulty with solar and wind, that they're intermittent, and we don't have inexpensive storage systems. Those countries that have a large amount of hydropower can, to some extent, use that to balance, use more of that when the wind is not blowing, but that's a limited number of places that can do that. Yeah, people are working hard on trying to get inexpensive energy storage, but I think, so in my opinion, it's likely that the renewables, intermittent renewables, will never be, at least not in the foreseeable future, will not be the total source of energy. They can be a contributing piece, but it's going to be difficult to get energy storage. But who knows? If we had the economic incentive, I keep coming back to the same thing, we have entrepreneurs, maybe we'll come up with things that we haven't thought about yet. For the doubters, yeah, I thought that my first book would make that clear, but it didn't. It didn't really. It turned out to be, it was too technical for many people. So I'm going to try. I'm trying with the second book, which I'm working on with the help of my oldest grandchild, and I'll try to make it in a language that is clearer. The science has become clearer about how the Earth's history, how the climate changed, and of course it is, and you can always, if you don't understand the total picture, you can always pick out certain aspects of it, and then try to use that as to confuse people. And carbon dioxide in these natural oscillations over hundreds of thousands of years was a feedback mechanism. As the planet's temperature was changed because of changes in the Earth's orbit, the tilt of the Earth's spin axis and the eccentricity of the orbit, these all, and the time of year that the Earth is closest to the sun, all of those change on timescales ranging between 20,000 and 100,000 years. And when that happens, when the tilt is more, then there's more sunlight on the poles, then that tends to melt the ice and snow at high latitudes. And that makes the planet warmer because it exposes darker areas. And then as it gets warmer, CO2 comes out of the ocean. And so it's a feedback in that case. The initial drive was something else, and the CO2 was a feedback. But now we're putting the CO2 directly in there. So now it's the initiator rather than a feedback. And it's hard to make that story clear, but in fact, the science is actually clear to the scientist. It is a little complicated, but it does not, in reality, cast any doubt on it. It actually makes it clearer. It's just that if people want to confuse the public, they can start asking detailed things and make the story complicated, and then the public says, gee, that's hard to understand. Maybe, I don't know, we're not sure. Let's not do something until we understand this better. So it's a problem.
Well, Dr. Hansen, thank you so much for your presentation, for fielding our questions, for coming all this way.
Thank you.